Okay, let's go and see how this one works. I'm not going to do the math here. I'm going to propose the math to you here, and I'm putting the same idea I did before to inscribe something, but I'm doing it in 3 dimensions, and I'll explain and propose the problems to you. And again, the idea is to find the percent of the shaded space. So I'll just box that here, percent shaded. All right, so let's describe it carefully and see how you do here. I have a globe, if you like, and I want to send it to one of my sons or something like that. So I'm going to pack it and put it in a box so that it fits snugly. So I guess to be a couple questions here. If the radius is 1, what must the dimensions of the box be? And once I have that down, what percent of the box would be empty? And I want you to try to figure that out on your own. I'm going to solve it tomorrow. So again, I'm taking a globe, maybe of the world or something like that, some sort of sphere, and I'm putting it inside this box. And I need to know what kind of dimensions the box needs so the sphere would fit snugly. And at the same time, I'd like to know the percent of the box that is empty. And then to contrast it, on the second problem here, I'm doing the same problem, but I'm using a sphere, again with r equals 1, but to make the math a little easier, I'm demanding that h equals 2. If you think about the problem, you'll see why. And I want to know what percent is empty in this case as well. All right? And I'll put that in here. And then, of course, the real question would be, and I'll go over here, which occupies more space, the sphere or the cylinder as proposed here. So that would all be, of course, like I did in the previous problems, in percent. So I'm leaving you with these 2 problems. I plan to do it. It's in my notes now. And again, no one can say they don't understand the problem. The problem is very clear. No one, you might not be able to do the problem, don't get me wrong, but you certainly understand what the problem is saying. Maybe you call it an engineering, packing problem. And this is precisely the kind of things we'd like 8th graders to think about. So on a video tomorrow, I'll do these. It's incumbent on the kids, self-motivated kids who are working hard to get ready for high school, to tell me which occupies more space and show me and try to figure out how we get up to that answer. And I'll certainly do that tomorrow. Okay, so that's about all we need to do for this. I just wanted to get that out there. Notice again, I went from 2D to 3D. And we should be able to do that easily. And remember in video 28, I gave you the problem where I inscribed a square inside a square diagonally, okay? So I'll leave that here. I'll upload it and send it to you and see if you guys can do that one.